Hello and welcome to my Let's Play GMod. I don't think I'm going to put episode numbers to these, just kind of weird things that I'm working on. This current project that I'm working on, I was thinking of originally working on it on camera, but, brain glitch. Anyway, I was thinking about working on it on camera, but after having spent quite some time on this project, I'm glad I didn't decide to bring it on the camera until now. Let's go have a look at it. Basically, it's the exact same thing that I was kind of screwing around with in the last episode, the balloon deployer and the, balloon there. But I have it hooked up to an E2 chip here. This E2 chip. Basically the idea is I was trying to come up with a stable balloon deployer chip to control the stabilization of a balloon deployer so that it would reliably keep the thing stable at a specific altitude and be able to handle shifting and things like that. As you can see, it currently isn't quite there yet. If we have a look at the code that I currently have here, it's kind of big and ugly, but we'll start off here. Basically, I have a PID equation working here. Let's increase this. I actually do all my editing in Notepad++, rather than this. I don't really like this environment for editing, but meh. Anyway, so we have the balloon deployer hooked up with a wire link, because I like wire links, they're pretty darn cool. And we have our PID equation here. Now, this PID equation I've just kind of been I've been trying to recreate from memory. I can't find all my previous GMod code, so I'm not quite sure how accurate this equation is currently. The PID equation is probably an episode in of itself, so I won't go into depth with it right now. But we've got the PID equation there. PID equation is probably like my favorite equation for GMod. Ever since I've discovered it, I've just been using it and everything. In my in my video of the factory that builds the little contraption, goes out and kills all the guys. I use the PID equation for pretty much everything in that, which is why everything's kind of jerky in its movement, but PID equation does a pretty darn good job. So anyway, we have the PID equation here. Now, originally, I was trying to manually put in numbers for the PID equation. For those who aren't too familiar with the PID equation, there are three parameters that you need to put into it. And you have the KP, the KI, and the KD parameters. And I was trying to manually put them in originally, but that really wasn't working out too well. I was getting nowhere. But then I had this idea. Well, it's kind of something I've kind of thought about ever since I've discovered the PID equation. Let's pull up the code again. And that it was to create a genetic mutation string algorithm for it to automatically evolve the parameters, which takes a while, but should work in theory. So this is basically it. It starts out with a bunch of random numbers for parameters, and creates 10 of them. Gives each one 60 seconds to run. After they've all run, it goes through, sorts them out by whichever one had the best score, which in this case is the score is the absolute value, well, the running absolute value of the error, or something like that. So every iteration it checks the absolute value of the error and adds it to the score. So in this instance, we want the one with the smallest score, because that will have had the least amount of error throughout its entire lifetime. We keep the top 4 high-scoring ones, and create the next generation based on them, or, you know, we fill out the other 6 slots with random numbers based on that, with a 10% chance of getting just an absolute random number that had absolutely nothing to do with them. And, you know, rinse, repeat. The output I have, or the information I have being displayed up here in this little thing here. It's hard to see through this thing, but currently it's on Generation 3. Or, no, it's finished with Generation 3. It's the top 4 numbers after the generation are the best results for Generation 3. Currently the KP of 15, KI of 60, and KD of 11 have so far proven to be the best. And that score is a ridiculously big number. I think we can probably improve on that. The Z there is the current altitude of it. I needed that there so I knew if I should be looking for it in the sky or on the ground. The C, KP, the CKI, and the CKD are the current values that it's trying. The CI, actually I'm not entirely sure what that is. I don't quite fully remember the PID equation. I remember that was important, so I just have it displayed. And the TTL is the time to live. That's how much longer this current one has in its try. So as you can see, it has 6, 5, 4, 3, 2, 1. Okay, now it's on to the next one. I have it set up so it won't duplicate the same one within the generation. So in a single generation, you won't have I guess we'll call them genetic strings for now. The parameters won't have the same exact ones, so you won't end up with duplicates. In a previous try of it, I forgot to have it check for that, so I had a whole bunch of duplicates, and it just ended up with just the whole generation was just one creature, basically. The stuff in green is for the balloon deployer itself. I was interested in the force, so that I didn't have to focus on the balloon there. It currently has a force of 0, which is why it's laying around on the ground. Oops. And it just gave it a real big force and then brought it back down to 0. It's part of the equation. I have it so that it runs the force that's to be applied to the balloon to a maxer that has it whichever number is higher between the force that's applied and 0, so that the force can never be less than 0. Which is, you know, why force is currently 0. When it was less than 0, it could potentially go through the ground. So by doing that, it just kind of plops down on the ground here. This is going to take quite a while, since basically every generation is about 10 minutes. Takes 10 minutes to run every generation. Now if I was smart, I'd build like several of these and have them run in parallel, sharing data. But I'm not that smart at the moment, so I'm not going to do that. I'm just going to let this one run. It's kind of interesting how the balloon is spinning and the shadow decal on it, or I'm going to call it a shadow decal, is not being adjusted. But if we move closer, it will start adjusting the shadow decal, as you can see there. So it looks a whole lot better up closer. But at the moment we get away, boom, it stops calculating that. It's just interesting. Also, another interesting thing is if we get over to the edge here, if we watch it, see this rather interesting line being drawn from where it was to where it is. It's an interesting little feature. Really makes it a whole lot easier to find the thing, keep track of it. So, I'm not quite sure why it was put in. I'm gonna guess because of this, but I don't know. Anyway, just kind of interesting and a bit cool. Now, while I'm thinking about it, I discovered something kind of interesting in the add-ons a little while ago. Tools. Let's see, I can't remember what page it's on. Well, basically, I'll talk about it before we get to it. That video where I had the factory where it was building that contraption, in it was I basically built it to show off the capabilities of a turret I had modified. The S-Tool turret that I had modified to be able to handle wire mod stuff. So you get a lot of cool things. No, that's buoyancy. But, to my surprise, somebody apparently took that and updated it to GMod 13 and made it available in this menu. Somewhere. Where was it? I think it was done by Mr. Daft Dude here, who updated it. I'm not seeing it at the moment. I have no problems with him doing this. More than happy to not have to be the one to update stuff. Let's see, where the heck is it? Ah, here it is. Yep. There goes, modified by KHM. And he even came up with this interesting looking little thumbnail for it. Okay, well, anyway. I'm gonna let this run for a few hours, see what comes as a result. Can I pick that up? No, I can't. So, I'll go ahead and I'll be back when I have a bit more to show. Alright, this thing has actually been going for a while. I just tried to record all this and it had a little menu thing up in the left, upper left, but the mouse kind of went crazy. Oops. Okay, the mouse kind of went crazy and everything just kind of stopped working there. Fraps apparently crashed, had a number of issues. And I was about to restart when everything just suddenly magically started to work again. Except that now the menu in the upper left-hand corner has mysteriously disappeared. So, let's see if we can put that back up. Not quite sure what happened. Let's see. Whoa. As you can see, the thing is clearly still going. Anyway, I've had this thing going all night. Oh, come on. Just hit the ground and stay there long enough for me to do this. I don't want to freeze it because that'll screw up the results. Anyway, so I've left this thing going pretty much all night, and it's, I checked, it was at generation 130. And, each generation is about 10 minutes, so I guess that's about, 1,300 minutes that it's been going for. the hell? Alright. No. I must have hid the GUI somehow. What the hell? Why are there 2 screenshot buttons? Oh dear, what did I just do? Fuck. Apparently F9 restarts everything. God damn it. So F5 and F12 both give screenshots, and F9 really fucks you over. Something is creating errors. What is creating errors? Wire, blah 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 blah. Expression 2. Attempt to index field player, null value. Blah blah blah. Okay, whatever. So, oh, and now the game is laggy. This is just good all around. Yeah, I'm gonna go ahead and just restart the game, and we'll come back. And actually, you don't know. I saved a screenshot earlier from when the mouse kind of quit working, and so I'll put that up on the screen. Just let me find it for myself. Where's my cursor? There's my cursor. God damn you. No! Let go of my mouse! Come on. Okay, we got this. Where are screenshots? There's screenshots. Let's see. I think this might be it. No, that's not it. Ah, here we go. Yes, so according to the screenshot, I got generation 135. The best score was, oh, wow. That's actually a pretty decent score considering what I had been dealing with before that. So, with the best score there, it's possible to at least partially recover what I had. So, yeah, I'm gonna go ahead and restart this and I'll be right back. I've just recorded half an hour's worth of video here explaining what I have in front of me. I went into fair depth explaining the mathematics behind it, and then I discovered that for some reason my microphone disappeared from the list of recording devices, so none of my audio was actually recorded. Yeah, which sucks because I built a rather interesting little gizmo that just hovered above there using a ranger and a PID thing. Anyway, so we're just gonna skip all the interesting stuff that I did before this because I don't really want to redo it all, and I'm just going to go ahead and quickly explain what I have in front of me here. Basically, I want to create a platform that uses an E2 chip to hover in the air in one place. I created this E2 chip over here, which I called pose, which, let me just pull that up. Here, open up editor. Okay, let's try that again. Open an editor. There we go. This is the code for that E2 chip. As you can see, it's just a simple program that creates 3 holograms and just continuously moves them into the forward, right, and up positions. And points the little pyramids in the direction, which gives us some useful information. It also outputs some additional information up there, some position rotation. Well, that's actually from the debug tool, but anyway. simplifies things for me. So basically what I have here is I'm going to be using 3 PID equations. Yeah, so I'm going to be using 3 PID equations to control this thing to maintain a stable platform here. One will control the Z location, the altitude. Yes. Okay, yeah, so one will control the Z here. Sorry, I'm about to sneeze, I think. Okay, so one will control the amount of force that's being applied to control the altitude of the platform. The other 2 will control the pitch, and the roll. So the pitch would be along the axis that the red is on. The roll would be along the axis that the green arrow is on. So what that would damn sneeze, either happen or don't happen. 1 second. Okay. So what was I saying? Oh yeah. Gonna have PID equation control the Z, the location on the Z-axis, by outputting the amount of force that should be applied by each of the thrusters. Well, yeah, so it's going to be 1/4 the total force that actually needs to be applied, since we're going to have 4 thrusters, and their combined force will add together into a single vector, which is kind of nice. We did some tests, or I did some tests earlier on camera, but unfortunately the microphone wasn't recording for some reason. Still haven't quite figured that one out. The reason why it's working now is because I unplugged and plugged in the microphone again. Now it's working magically. Ooh. My pop filter's slightly off. There we go. Anyway, so yeah, the other 2 PID equations will actually be outputting a multiplier for the force to control the axis that it's on. Now, if I had the thruster here, here, and here, that'd be fairly simple. And when it's perfectly level like this, they would get each thruster would get a multiplier of 1. And 4 times that would be the amount of force needed to keep it perfectly stationary. Let's see. But because I have them each in the corner here, each thruster is actually going to be affecting 2 axes. And since there's 2 of them on each side to affect each side of the axis, each one will actually get 0.5 from each of the equation, and that'd be added up. So when it's perfectly level like this, each thruster will still have a multiplier of 1. But see, if it's like this, this side will have multipliers, or will be greater than 1, while this one will be slightly less than 1. And I'm just going to grab some arbitrary numbers to kind of explain this. Since it does not need to change the pitch, each one will still have 0.5 from the PID equation that's going to be controlling pitch. But since it does need to adjust the roll, so yeah, because it needs to adjust the roll still, it would be getting, this side would be getting slightly more than 0.5, and this side would be getting slightly less than 0.5. Let's just come up with arbitrary numbers that might or might not be correct. 75 on this, no wait, that would be, yeah, 0.75 for both of these on this side and 0.25 for the ones on this side. And that would get added to the other PID's 0.5, so this one would actually have 0.75, whereas this side would have 1.25, I believe. That's basically how it should end up as a result. These are vector thrusters. I did that so I can do some cool things later on with them. Mainly like having them point straight down or something for the moment. But I could probably use them to control the roll as well. And maybe even move the platform around the map. I'm not sure about that. That's still kind of a thing to be done in the future. Yeah, so I'm gonna go ahead and work on that E2 chip, and I'll come back once I've got something worthy of presentation. Alright, I have a quick prototype here, although it's just one of the PID equations, the elevation equation, and I want it to keep upright. As you can see, I already have a constant value selected here. I want it to stay at an altitude of around 100. It's currently at an altitude of 19, so it should be a little off above us. The P value will be 1, the I will be 0.1, and the D will be 0.01. No real particular reason, I'm just going to do that. No longer need it to be there. And it should go immediately once I have this last one hooked up. Cool. Alright, what's the problem? There we go. Haha! I'd say that was fairly successful. Point 3. Point 2. Perfect. It'd be pretty good. Yeah, I'd say that's pretty stable right there. Now if I multiplied everything by, let's say, 10. Oop. I think I might have it. Whoa. I I've got it. I have it. This is perfect. Look at how stable this is. Awesome. Means I now have the pit equation correct. Alright, time to reveal my corrections. Open up. I had these backwards. I think that was pretty much the only real adjustment I made to this. Maybe something around here. Anyway, this is the current working code for it. Look at how stable this is. This is awesome. Seem to have some issues here, though. Despite the fact that it's stable, I can't jump around on it. Which is interesting. Used to be able to jump around on this. Must be a change with the 13th version here. Let's increase this the values of this, multiply them by another 10. So 15, that. Okay, now it shouldn't even wobble if I flop down on it. I think I ended up getting stuck in it or something. Can't seem to walk anymore. Alright. 0.00. Okay. But all in all, I'd say this is pretty darn stable. Probably be even more stable if I let it thrust downwards. This is pretty cool. Whoa. No. That's awesome. Oops. Nope. Trying to jump forward again. Can't jump on this. Something I keep forgetting. Yeah, nice, fairly smooth ride here. This is awesome. Okay, you know what? I should end the episode here. So, once again, I am KHM, and we'll see you in the next episode.